Okay, so what we want to do in this video is just have a look at some of the rules of integration that we need for doing the differential equations, because a lot of it requires on us doing integration, and we just need to know these techniques well. So our basic integration of polynomials, so x to the power of n, we add 1 to the power, we divide by the power, and we add the c. So pretty simple to start off with. If we have a look at ax plus b, so some linear function to the power of n, then we can manipulate that one to add 1 to our power of the bracket, but then we divide by the a, which is the coefficient of x, and the new power, which is n plus 1. So it has a little bit more involved in that one there. So that's just what we can use for polynomials. If they get a little bit harder than that, then we have to use some other techniques, so which we'll have a look at in the rest of the document. For trigonometry, well, if we remember our little notification over this side, where sine differentiates the cos, differentiates the negative sine, differentiates the negative cos, and that differentiates the sine. For integration, we just go back up the tree. So sine will integrate to negative cos, so we see sine to negative cos. Cosine integrates to sine. And the only one that's different is the tan. And this integrates to sec squared of x plus the constant, which, again, you'll see it in some of the notes. Alan writes sec squared x as 1 over cosine squared of x. So just be wary of that. You can change that round, but generally in courses we have tan x integrates to sec squared x there. The other ones we want to look at is looking at integration of exponentials and logarithms, because that's going to be part of it as well. So integral of e to the x is the same as the derivative of e to the x. So remember, this is all anti-differentiation, so we're just reversing our rules. A little bit different when you've got a linear function, e to the ax plus b. The integral there would just be 1 on a e to the ax plus b. If it's any other function in this power here, then we're going to need to use some substitution, and we need to have a function that's a little bit different, or it could be integration by parts need to be done as well. So we need some further techniques. But if you see it in that form, then you'll know, then that's the integration we have. Now we can't integrate a log function just by itself. As I said, have a look at the section on integration by parts for that, and we'll go through that in another video. So we can't actually integrate a logarithm function, but we can integrate to a logarithm function. So if we remember, for the derivative of the log of a function of x was the derivative of the function over the function. So the derivative was going that way, integration goes the other way. So what we're looking for is the derivative of a function here over the function itself, and if we've got that situation, we can integrate to a log function. So it'd be just log of that function there. So it may need a little bit of algebraic manipulation in the work here. Sorry, I shouldn't say algebraic manipulation. You might need some manipulation with the constants that are involved. So the coefficients and multiplying by a constant there to get there. But that's as hard as you have to do it. But you're looking for the derivative of the function over the function. So we'll have a look at some other videos at substitution and integration by parts.